Hello, this is Billy Atkins. I'm going to really quickly run through my assignment three using convolutional neural networks for image upscaling of a 2828 image to a 56 by 56 using a autoencoder. So the first step is that I did was I imported a bunch of libraries. I can go through and explain some of them, but one that's important is that you have to open up this terminal and then run. I'll actually pull it up quickly just so you kind of see what it looks like. You essentially hit terminal, and if this connects, it'll appear here, the command line, and then you just type in this because it's not automatically booted into Google Colab. But essentially Torch Info just helps print a summary of what your model looks like and can help make it a lot easier for understanding the autoencoder. And whenever you are generating the image and you're comparing it, you want to be able to see what your input and your output is. So if you're still at a 28 by 28, but you're supposed to be upscaling it, it's helpful to see that. So for getting the data, I actually had some trouble with this, but I tried to pull it all from Google Drive and read it that way. It was like 50 minutes each time to read the data, and all the images. And that's too long. So I ended up mounting the drive. This is copying the path from my Google Drive that has the training and testing images, and then creates a local environment in here, which I haven't ran it and I'm not going to right now, but it creates an environment here, and then you see and you'll be able to see this right here, the train folder and the test one folder that also has the contents of the unzip, wherever you unzip the test one, the test and the train data. And then I essentially converted them to RGB. I used grayscale. I used both whenever I tested. Of course, grayscale is going to have a little bit better quality, but I wanted to do both. The way I did it was I handled change this to L or RGB, and then you also have to change your channels. So if you scroll down, like in this part where you transpose it, this part has to equal one because you're not whenever you're working with grayscale, it's one image or one channel, not three. And then whenever you're building your model here, this also has to be one. Um, but yeah, essentially this is just taking all the data from the train, and then I have the one that's also for tests as well. Takes all of the data, image, resizes the image and stores it in these lists. And then I printed the first element from each one of the 28 by 28 and the 56 by 56 of the training data. And so you can kind of see how it looks as a vector. And here, this is just converting it, normalizing. This is the transpose that you have to do uh, for actually getting it on the correct axis so you can load it into the model because it won't understand it if it's not transposed. And then we created a noise factor, which this part was given through the tutorial, and most of this was here, so I won't go too far into that. This was also mentioned in the tutorial too. Creating it into a, or I guess this was actually part of the instructions, but it's a lot more helpful to actually load it into a little NumPy file. And so I created a training and test for the 28 and the 56, which I didn't use all of this information, mostly just the input information, but I wanted to have everything just in case for future testing or future implementing with this kind of model. So we have the mp dot save, saves it, and then we load it back in, and then it comes up as a file here. So it's a lot, it helps a lot with training data if it's already loaded into the runtime environment. This is my model. The tutorial, it went down to a 4 by 4, I believe, and I just didn't think that was an excessive amount of squeezing for it. So my encoder only takes it down by one scale factor, which right here you can see. This is scaling it down by a factor of two. So 28 by 28 divided by 2, 14. So this is the three, and this is also the three channels I was talking about. Since my latest iteration was using RGB, I had the three channels and went from there. My activation functions was ReLU or ReLU. And then my decoder, we upsampled each time because if you upsample once, back to 28 by 28, and then upsampling again takes you to 56 by 56. I saw that there were some different modes, and I tested nearest as well, and it was okay. And then I tried bilinear, and it was pretty good. So I went with bilinear for mine. And also ended on a sigmoid activation function because whenever it's normalized, it'll be between 0 and 1. And the result or your the prediction for the model is better or the accuracy. This part was all pretty much exactly the same. Besides a little bit, I tried changing the batch size at first to 32. Kind of helped, but not really. So I left on one, went back to 128. There's the noisy train, and then I converted both those to tensors, which is also in part of the which is also in the tutorial that we had went over. One big change that I had made was I used MSE instead of the BCE, the binary cross entropy. I found it to be a lot better. Whenever I did binary cross entropy, the images were kind of pixelated, and then MSE was more smooth. So I liked how it had come out better, but I don't think one's much better than the other. Well, also the loss was a little closer to zero for MSE as well, so that was one other reason why I thought that would have been better to use it. And then instead of eta delta, I went with atom, and then I changed my learning rate to 1 e to the negative 4. Um, and then of course model parameters, pretty self-explanatory. I did find a library for this wrapper here that you can use, and it creates this progress bar, which I thought was really cool, so I decided to add it. I did 100 epoch on my last run, but I did 50 the first time I had tested with bringing back an RGB, and I noticed it performed really well, so I started doing 100 epoch, but I signed up with my personal account for the because if you link your school email to it, you get access to the Colab Pro. So I ended up using the G4, and training the data was a lot faster than running my CPU. So yeah, 100 epoch didn't really take too long. And you can see my loss here was really good, actually. It was really good. So whenever I was testing with the binary cross entropy, it was 0.6 0 instead of 0.017. So it was a that was a huge change for me that I knew I had to jump on whenever I had first saw that. There's also a writer up here so that we can write a summary that will appear here, but also I have this too that also has the input size and it prints it down here. And this also is loading in the model, saving the state, and then loading in the path. And this is where I was talking about how this is really nice for seeing what's happening with your model, how many parameters you're having, and what's the final output shape. Because this might looking at this without comments is kind of hard to tell where what your input and your output layer is. So the shape here makes it really nice for kind of just getting to understand what's happening. Um, and then scroll down, loading in the model. This is the test part, and a lot of this was pretty much copied from the tutorial, or I'd used a lot of that. Same information. Converted it to RG. I did add this, converting it to RGB, and then I believed it was already resized to be a 28 by 28 for the predicted input. This is also the same. Converted the ground truth to RGB as well, which it already was, but just for to be consistent, and then had my generate image permute, and then the rest of this was the same as the tutorial, and this is my last iteration. I used the same test that he had used in the tutorial, the same test image. I thought it turned out really well. I did have to turn the noise down a little bit. It was too much and it wasn't noticeable. So once I turned it down, it did help quite a bit, but it was still able to reconstruct the image. Just from looking at this, you can tell this is a cat. So I thought this was pretty good. So yeah. Anyways, thank you for listening. I appreciate it.